Section 10.2 is called factoring by grouping. So it is a factoring technique, and this is specifically for when we have four terms. And remember, terms are pieces of a polynomial that are added together. So let's see what the process is. It says, when factoring a four-term polynomial, so four pieces added together, we're first going to look and see if there's a GCF in all four terms. So GCF, remember, stands for greatest common factor. Let's write that out. So if we can divide everything by something, we should do that, right? So if they all are divisible by 2, let's do that dividing by 2, pull the 2 out as a greatest common factor. Then what's left, we're going to separate into two groups of 2 terms each and factor the GCF from each of those 2 groups. And then hopefully there's a common binomial. That means that we need to see something matching. So factor out the matching remainders. All right, so let's see what this looks like. I know, right? Like when it's just, oh, here's a process, it doesn't really make sense. So what this is gonna look like. Let's just look at example A, and they sort of warn you that these are not what we'll typically see, because what they're actually doing is jumping to just step 4. So we're gonna just look at step 4 and what I mean by factoring out the matching remainders. So this is what it's gonna look like after we factor the GCF from each group. So we'll have a GCF factored out from the first 2, a GCF factored out from the second 2, and ideally these parentheses match, and they do. So if we have these matching, what I called remainders there, then we can factor them out. So they both have an x plus 7 factor, and so then what remains is x squared plus 9. So it's a little weird. If we wanted to check that this is right, well, it's like the x squared is times the x plus 7, the 9 is times the x plus 7. It's not really a FOIL because it's in this very contrived form because we're just highlighting this last step. But let's see what this looks like in some other examples. So here we're looking for parentheses matching. This one's a little different because there's nothing in front of these parentheses. So if that's the case, we want to put a 1. Sometimes the greatest common factor is a 1. That happens. So in this case, the matching parentheses are still the y plus 2. But what's left is y plus 1. So that 1 needs to be there. We can't, it's not just a y because we need this to still be there if we are to multiply it out. Okay. Hopefully that's sort of making sense. Let's try this last one. So first we check the parentheses match. Awesome. So it's those parentheses we can factor out. And then what's left is t minus 2. So this is what the last step of factoring by grouping will look like.